you're listening, and we're recording. So, mic is hot. I can hear everything you guys are saying. I can hear everything you guys are thinking too. So, anyway, would anybody want to share their emotion drawings, their experimentation with the different stages of emotion? This will make sense once we get into our animation principles. No takers? Totally fucked. No worries. Okay, so the principles of animation. This week we're going to be focusing specifically on these three: squash and stretch, anticipation, and staging. Has anybody heard those terms before in regards to animation principles? Not shy, see a thumbs up. Okay. Here or there. Okay, so that's good. That means we'll have something to work with here. There's 12 total principles, which I've attached in this video right here. We'll watch the one on squash and stretch today. I'll give you some demos, and I have an activity. We'll see how well it works, but a little flipbook activity practicing squash and stretch. And then later this week and after the break as well, we'll be finally getting into some digital stuff, some art tools on the computers later this week. But today we're just focusing on the more analog style with a flipbook. Okay, so first things first, I want to watch the first principle of animation here, squash and stretch. You can kind of come up with, or you can kind of assume, if you haven't heard about it in animation, you can assume what they probably mean. But we'll go like this. Mute this real quick. Sorry, we'll talk about it more here in just a second. The classic example of squash and stretch is that bouncing ball. And you guys will get some time to think about that. So let me open up my sketchbook here, move some of my stuff around. I got to turn on my camera. There we go. Oh, it is way off. I don't know what happened. Sorry, guys, hold on. Okay, so there on the Zoom room, you should be able to see in more detail what I'm working with here. Let me stop screen sharing. Don't need that right now. Okay, perfect. That's what I was looking. All right, good deal. So the main idea is, I gotta find my Sharpie over here. The main idea is with squash versus stretch, you do need both of them, but they serve two very distinct purposes in the realm of animation. Squashing is for impact. Because remember that video mentioned that squash and stretch is the way to communicate an object's mass, but also its momentum and its speed. And all three of those things are going to be influenced by how much an object weighs or how much of the object there actually is. So squash is typically reserved for impact. It's a little bit more slow because it has that chance to hit something or something hits it or it's landing somewhere. So it's a lot slower than than its alternative of stretch. And then this is typically going to be horizontal in its expression when we're animating in 2D, which is where we're going to stick to for this class purposes. So the squash happens in like this if we have a rectangle. Squash happens inward like that, and then the rest of the mass moves outward in the opposite direction to create that extension effect, that impact effect, and things like that. And just a couple notes is more squash. Forgot how to write. More squash equals squishier object or softer object. And vice versa, less squash meaning stiffer or harder object. Stretch behaves in a similar and opposite way to squash does, in that instead of for impact, stretch is usually reserved for speed. The faster a thing is going, the more it is going to stretch out, the more elongated it's going to become as it gets further and further away from its origin and picks up more and more speed. So since it's speed related, it's going to be much faster. And because it's because it is faster, it is also more varied and easier to experiment with and mess around with here and there. And then this is not necessarily horizontal. This can be horizontal and vertical. And since these things are principles, these are just my experience with these principles. There are defaults that come with it, like folks far more experienced than I have explained in better than I ever could. So I will find resources that will do that. But these are generally rules that you do have to stick to, is ultimately what I'm saying here. So typically when we're stretching something, if we imagine the falling example, instead of squashing on this y-axis, it's actually going to stretch along the y-axis. So if we have we start with a ball, start with a sphere. As it falls and picks up speed, it's going to become elongated, but it's not going to lose any mass. So that pressure comes in from the sides, but extends it outwardly through the y-axis, the opposite of squashing does. So I want to try something else real quick before we get into our other thing. Might be a way to do this. Sit tight for just a second. You can copy these notes if you have not yet. I want to try, because I did a digital animation. I want to see if I can share this screen from my iPad. So I'm just going to try that real quick. Okay, so what I'm gonna do is pause this for just a second. I'm gonna close this Zoom room. We're trying something new here, so just bear with me. You'll probably just have to leave and reconnect at this point. But we're gonna focus on applying, oops, sorry, squash and stretch in a quick little example here. I guess I keep forgetting. All right, this over here so I can see what I'm doing. All right, sweet. So in your guys' sketchbooks, before you get the flip books, I want us to take a like an attempt, kind of a draft, a first version that we're gonna try here in 2D without any of the flipping, without any of the actual animating happening. So when you draw excuse me, I am not the only one who can do this. There's lots of different ways that you can experiment here. Let me turn my light on. I like to do my squash and stretch animations kind of as a ball rolling off of a ledge like this. So I'm going to create a little ledge of sorts. Okay, good. We are recording. And then I'm going to start with my ball, my sphere, kind of teetering on the edge here. And that's going to give me a feeling for how big my ball should be. This should be the total amount of mass. If you think back to I can't remember which science it is, but law of conservation of matter. This ball is not going to increase nor decrease in mass. It's only going to change shape or change form as it moves through the extent of our animation here. So then, just kind of eyeballing, this is me just kind of drafting out this animation. Right as it teeters off, right as it falls forward, the size is going to maintain about the same size. So I'm just going to try and draw the ball right next to it. We've hopped off the edge here. We haven't really gained any significant speed yet, so we're not going to be stretching out too crazily, nor have we had an impact. I'm going to draw a little floor right here for us to bounce off of. We have not had any substantial impact yet, so we have neither squash nor stretch in these first two initial frames of our animation. But as our ball picks up speed, okay, I'm going to elongate it just a little bit because it's starting to fall a little more. Actually, I'm not going to elongate it quite yet, but I am going to add some more distance from my starting point to my second point to my third point. So my third point is going to be right about here. Just try to draw about the same size ball as best you can. Now we're picking up some speed. So now the distance between these steps is going to increase very slightly, very incrementally, as we move our way towards the floor or towards our impact point. So the next, I want to maintain, just kind of eyeball as much as possible. My ball is starting to stretch out a little bit as it picks up speed. It's going to warp form. Okay. It's going to really pick up some speed. So it's going to have a very small top and a much more elongated shape like this. Very small top, very elongated to really communicate the amount of speed that the ball has as it increases. So if we imagine this is slow, we're picking up speed, and then we're going really fast right down through here. And now I'm going to draw the, just for example's sake, draw the impact frames, the squash, or the squash half on this side over here. This is our stretch equals speed. And then over here is going to be our squash equals impact. So we imagine our ball has picked up a considerable amount of speed right before it hits the ground right here. So once it hits the ground, it's going to continue that speed. So we have our impact, something like this. Notice how I'm just kind of making it thinner as it moves with gravity. My experience in animation is two-dimensional. So as it goes down with gravity, it increases in depth. Right where it makes that impact, right where it initially connects, right here, that is where our first frame of squashing is going to happen. So if we imagine, I wish I could do like a cross section or like something like that. Anyway, so this is where our squash is going to first happen. And since this ball, depending on how squishy or how soft you want it to appear, is how much it squashes in this impact frame. So I want my ball to be not super squishy, not like a water balloon, more compared to like a tennis ball or like a kickball, I guess. So my squash is going to impact like this and translate the direction or the directionality of the energy. Instead of going up and down, it's going to translate it to a left and a right. And then there's one more step that sells your squash is you return to a little bit more stretch, not as extreme as before, but a little bit more stretch. And then you squash a little bit more once again. This is called in-betweening, which we'll get more into later in the animations or later in the unit. We're still squashed, but we're reapproaching our full ball back to normal. So the squash process, right at the point of impact, you translate the up and down into left and right, stretch a teensy bit more, then you squash a little more, and then you're pretty much close to back to normal. So if I were to repeat these steps on my digital drawing method, which is what, oh, I'm still scrolling. Let me see if that recorded real quick, sorry. Okay, it didn't, but that's fine. All right, so if I were in my digital drawing tools, which we have access to Photoshop, I know Krita also has one. We don't have Clip Studio Paint, but I am gonna do the worst possible example here by just drawing it on my screen. Okay, so I'm gonna set, can you guys see that red okay? It's a lot easier to see behind me as compared to on the Zoom room, but okay, so here's my ledge. I'm gonna go to, I use Procreate, oh, not Gallery. Procreate has a setting here. If you click this wrench, you turn on Animation Assist. And then every time you want to add a new frame, it'll automatically add a new layer. So here's my ball. When you animate, you got to draw each step along the way. You'll see here in just a second why. So here's my ball. There's my flat surface, which is super cool to see. And try something. Stop. I'm trying to make the canvas black. Whatever. Okay, it's not doing what I need it to. So if we go back here, sorry about that. So here's our first frame. Here's our initial sort of perspective. If I add a frame down here at the bottom, it's going to leave a lower opacity, a lower like ghost version. It's called an onion skin behind so that I can make my reference drawings after that onto the next frame so that I have consistency. So I'm going to draw my similar size ball, not far from the starting point. Okay. Sorry, these are trash. Okay, let's see what we're working with under here. Next ball is going to have a little bit more distance. Still maintaining a pretty decent original shape. Now we're going to start stretching out a little bit. A little bit more egg shaped, a little bit more lemon shaped. Okay, now we've picked up some serious speed. So our ball is going to be quite a bit more stretched out. And then right at the fastest point, right at the impact point, I go back and realize now that I forgot to draw the ledge and the floor in each of these examples. So let me do that. Ledge, floor, and then finally we have ledge and we have floor. So this is where my squash has hit its max speed, its max amount of go. Okay, so sorry. We try new things in Mr. Blakeney's class. Okay, so there we go. My squash or stretch has hit its max amount of stretchage, which means it's going to hit its top speed right at the impact. And then after that impact, once I add my little legend stuff here, I'm going to try to translate as much of that stretch into squash as possible. Okay. We're going to add a frame. There's a little bit of distance in between my two onion skins here. So I'm going to add a vague kind of ball shape that's a little bit squashed. It's a teensy bit stretched out at that point. That actually might be too much. That's still too much. So we're going to still draw a fairly squashed ball and then add a gently, that's too little, just a gently stretched ball like this. And then right about now, we should be on our back to normal ball size or our sphere size like this. And I forgot to draw these again. So something to keep track of, you got to draw your background every time you make a new frame in your animation here. So if I play this, you can see how the ball, it's not awesome, but you can see how the speed is translated and how the impact is translated, as well as the mass of the shape, by only thinking about how is the ball going to squash and how is the ball going to stretch. So I'll export that and put that into our thread. And I just realized how much time I have been talking. So we're going to do the flipbook activity tomorrow because we only have 8 more minutes here. What you can do is something like this, where you're kind of plotting out how you want your ball to drop, how you want your, just experiment with squash and stretch to kind of get a feel for how the thing moves and translates and stuff like that. But again, this was mostly an introductory day that we're going to continue expanding on with a flipbook activity tomorrow. So you guys will make your own bouncing ball. And that's the first animation principle. It's where everybody starts, is squash and stretch. So does anybody have any questions in general? Anybody have anything they want to share? All right, I'm going to wrap up this Zoom room, post all of our stuff. And thank you guys for listening. I appreciate it.